All right, hello everybody. Today is the 12th of April. This is Dallas Personal Robotics Group Robot Builders Made Virtual. We seem to be entering the summer phase and being easily distracted by any number of different things. So that's always good. So we'll take our discussion around the table with robots and related things, whatever else hits our fancy, and we'll take it from there. So to start us off, I think, Paul, you said you had something to discuss perhaps, or present or ask.
Yeah. So I'm going to, I sent a link out to the mailing list on this new project that one of my friends clued me into called Open Mower. And in essence, it's a guy in Germany who's taken the approach of modding an off-the-shelf robotic mower, which, as you guys know, is what I'm doing with my robo mower. And so he's rather than leave the existing electronics in place, he's substituted the OEM electronics with his own electronics. So I've been digging in over the last couple of days to the software and have a demo of it working, and it's really, really good stuff. Very applicable to mowing. So I think Ray would be interested in this, and interestingly, it also has a CNC cutting aspect, which you'll see in due course. So with that, let me present my window, and I'm going to start off with a video of that he posted. Are you guys seeing this step one teaching the map?
Indeed.
Okay. So
you have to teach the mower where it should mow.
Are you hearing
this
the
is done
audio?
by driving the robot
We
around
are.
using a remote control. Here you can see my dad controlling the robot using a standard Xbox gamepad.
So he's making a map
Areas like
of
trees
the
can be avoided
mowing
by
area at
teaching a
present.
no-go zone.
Can
This
you
is
full
also done
screen it?
simply by driving around the areas.
Now he's mapping obstacles.
Paul, can you make it full screen?
More than one mowing area, you can just repeat the whole process.
Looks good.
Should I play it again from the start?
At this point,
Sure.
the setup is finished and your robot is able to mow.
Why not?
So this is the guy, the project lead.
As I have mentioned before, you have to teach the mower where it should mow. This
This
is
okay?
done by driving the robot around the area using a remote control. Here you can see my dad controlling the robot using a standard Xbox gamepad.
So he's making the map here. But driving around the
Areas
boundaries
like
of the
trees
mowing
can be
area.
avoided by teaching a no-go zone. This is also done simply by driving around the areas. If you have more than one mowing area, you can just repeat the whole process. At this point, the setup is finished and your robot is able to mow.
So now it mows 2 passes around the perimeter.
First, it drives around the outline to ensure that it will not cross the perimeter even during turns later on. Then it will mow the rest of the area in a linear pattern. If you like this project, don't forget to like this video and subscribe to my channel for future updates. base for this project, I'm using an off-the-shelf robotic mower. This is because you get most components in a neat package for around 400 euros. You get the main mowing motor and the 2 drive motors with encoders on it, as well as a battery and a waterproof sturdy enclosure. This is cheaper than buying the components individually. All electronics inside are replaced by custom ones. And the designs are of course open source in the OpenMower project. This mower is very hacker friendly because all electronics are connected using standard Molex connectors. But now let's look at the custom hardware. The main processing is done by a Raspberry Pi 4. It runs the larger part of the OpenMower software, for example navigation and localization. All real-time tasks are handled by the small Raspberry Pi Pico microcontroller, which is located below the RTK GPS board.
He's holding a.
The 3 motors are controlled using 3 XESC motor controllers. Those are also an open source project of mine. There are also some connectors for emergency stops and a user interface, as well as a sound module.
See the
The user
GPS
interface
antenna on
board
the right.
fits in the original shell, and so the buttons can be used as expected. If you want to build your own OpenMower, check out the GitHub page and join the Discord if you have any further questions.
Okay, so let me switch over here, and so that was the promo video. So I've built the software, joined the Discord server, and the guy there's actually a pretty active community. Yeah, tons of people are like super excited about this project. I just want to say that to temper potential unwarranted enthusiasm, that this is a tiny mower that he selected. It has about a 7-inch cutting width, so about as wide as my hand. So not suitable for mowing Ray's ranch or my backyard, but conceptually, it's very applicable to applying to a wider robo mower like mine that has, for example, a 22-inch wide cut path. So now I want to switch to a demo of the software. So let me just fire up that and then present the window. Are you guys seeing the mowing area?
There it is.
So this is a and I just got to change a parameter here. Give me just a sec to make it work properly. Okay, so this is a mowing area. So there's a simulator that's a part of this project. It's a 2D simulator, so it's not Gazebo, but it does simulate the robot's motion, and so I made this. So I created this outline simply by driving around like the guy's dad did, driving around some perimeter in RViz using the joystick, using a standard ROS joystick like Chris and I have demoed before. The mower starts off in this position. This blue arrow is where I've placed a docking station. Turns out that I should have placed the docking station outside of the mowing area, because you'll see it drive over the top of the docking station. I haven't quite figured out everything about this software yet. It does have 2 types of area: a mowing area and a navigation area. And the mowing area is grass to be mowed. The navigation area is for moving between spaces or between the dock and the mowing areas. I haven't really figured out how all that works yet, but this red area, red line in the middle of the mowing area is where I created an obstacle, and the workflow is you drive around the mowing area first, and then then you tell it to stop capturing the mowing area, and then anything that you create after that during the same capture session is considered an obstacle. And so it draws this red boundary, and you'll see that it mows outside of that. So now I'm going to kick it off, and it does assume that it starts off in its dock. So it starts off doing a 1.5 meter reverse movement. So I just click the manual start mower in the RQT reconfigure tool. And so it's backing out of the dock here. And now it pauses for a while as it runs. So this is the 3D printing section. It uses something called Slicer that is apparently a 3D milling program. I don't know it, but Slicer produced that the pattern you see, which is actually the tool that a milling machine would follow, or the path that a milling machine would follow if it were routing out some piece of work. So here it's also using the ROS Move Base software, or ROS Navigation Stack, I should say, to I don't think I quite got the right logic. Let me just check the parameters. FTC planner, max speed angular, FTC planner, max speed angular. Bit worried about maybe it won't work.
Grenades and bocce ball. It's pretty close.
Oh,
you know.
Well, maybe it will work. We'll see. We'll see in a sec. There's a parameter, the dynamic reconfig parameter that you have to change to get the simulation to track the path decently.
It's pretty clever using a slicer. I mean, that's, by the way, anybody who's doing 3D printing will know slicer. I think it was the original open source slicer for riprap.
Okay.
Isn't that what Polyprinting uses?
Now it's very sophisticated, but you can see what they're doing here is the red line, which is the perimeter in your 3D printing, and the green line is its infill. So you probably have some sort of infill number. But the other thing that's cool is that means that it's using the G code, which you said, I guess. So it's using.
No, I didn't say anything about G code. I don't know about
Okay.
G code.
Yeah, but I mean, it looks like it's using. Right now, it's going around the edge a couple of times.
So now you can see it mapped a global path off to the beginning of the infill region.
So does that mean that Paul then just has to define like a 22-inch nozzle?
Really,
Well,
really
yeah,
wide.
someone on the discourse server was joking about that. They were saying width of 0.2 meters. Okay, good. I got the parameters set right. So without the dynamic reconfig, it was like blasting off into space and disappearing. So it's also based on RTK GPS. It uses the ZF9P module. That's what's in that ArduSimple controller,
RTK.
and that's the chip that is in the SparkFun RTK GPS2 module that I've got mounted to RoboMower now. So now it's just sort of pretty mechanical. It goes down and does all the green infill, and then it maps a path over to the blue section, cuts that, and then it heads off to the base. So this solves, as you can imagine, a lot of problems that I honestly didn't know how to solve. I know Chris has figured out how to use the ROS navigation stack, but it's something that I'd never messed with and still haven't. And it's so anyway. So there was one problem that I was like wondering, okay, how am I going to get to understand the ROS navigation stack? And then the other is, how do you get this pattern that you want? I'm still not sure it's completely solved but anyway, for what it's worth, this is what it does. So I can leave this playing and we can like talk about it.
Yeah, he must be setting some waypoints if he's using the navigation stack. Either he heavily modified some parts of it, or he basically he set some waypoints, you know, where he needs to make the turn. Like right now, he's reached a waypoint, and then he's setting another waypoint
Yeah.
here, and then another waypoint. So, you know, because the ROS navigation stack takes you from point A to point B. Now you reach point B. Well, now you need a new destination, right? So I think that there must be multiple waypoints going on here.
So the console says it has a global plan with 393 points. So there's a state machine that runs through the various phases, and it's
those must be those waypoints. Yeah, so there maybe will be something already in ROS that says here are the waypoints. You know, may not, you know, you may be able to give it to the stack ahead of time. Yeah.
Yeah, he also says in his documentation that he's using Slicer as a library, not necessarily as a standalone module. So relative to Doug's comment earlier, he may not be using G-code per se. He may be getting waypoints out of the library, the path planning library.
Yeah, well, G-code would give him waypoints. So I mean, I'm sure if he uses Slicer, he may be translating the G-code coordinates into some other value, but they would, I mean, this, if you didn't know better, you'd be looking like you were looking at a 3D printer. I mean, you see similar graphs as their output, and you could adjust like the distance between the perimeter and the closest infill. And in fact, they usually have an infill overlap of the perimeter a little bit in 3D printing. But I mean, it's a really clever use of existing software. I mean,
isn't it?
Yeah, it's really clever.
So the next level would be like if it could raise and lower the wheels, then you could do like a tiered pattern in your yard. The grass.
Yeah,
So here you can see that the global planner has kicked in. The state machine just said it's finished. It switched to state 2, then it reached the goal position, then it switched to state 3. It said post rotate is finished, then switched to state 4, and now it says
looks like it backs into its
goal reach.
start.
Yeah, if it doesn't have enough room, it backs in. I don't know. I'm guessing that's a ROS navigation stack thing.
Yeah, quite possible. I mean, I sort of got it to work, but only barely, and it never really worked well for me. And you know, robot was doing quirky things at times when it's getting close to obstacles. So it's.
So notice that there's a yellow line around the tree or around the obstacle. So it's about to plan a path over to the yellow line and then mow the yellow line, and then that will be the end of the mowing sequence, and then it'll head back to the dock. And currently, it is being charged.
I mean, with G code, you could, it's looking at the obstacle as a hollow piece. So in 3D printing, you would think of it as a hole.
Yeah.
And going to the charging station is just returning to when you're finished, you return to a specific location in your 3D printer. Usually what they do on a 3D print is wherever it stops, it just does a Z up, but it can move to an XY position and then do a Z up. So, I mean, I can see if you think of it as a 3D printer, it really, really is kind of clever. We had another thing you might want to look at, Paul. God, I don't know, 2 years ago, we had a gentleman come in who used the donkey car stack to mow
Ross
lawn.
Melbourne.
Yeah, to go back and forth. And he explained how he did it. I can't recall exactly how he did it, but you might want to look at that video because he was essentially creating a mower too. So that video is on the website. You just have to slide back in time until what was his name? Ray?
Ross Melbourne.
Ross Melbourne. Yeah, he's from Australia, if I remember right. And
I thought he was from the UK. I don't know where he was from.
well, I thought he was from Australia
Is that
originally.
the guy that has that really janky plastic bladed mower?
So welcome everybody. Today is Saturday, April 9th.
He demonstrated it with a pretty high-end RC car. It had
Okay.
dual
Okay.
wheel steering.
Yeah.
All right. So no,
And
someone
I
different.
remember that.
Yeah, and he was using it also. Yeah, I remember his RC car was well made.
Yeah.
And I mean, it was highly modified. Okay, it wasn't just a model from Hobby King.
Yeah.
He also, I know he used Google Earth in his demo, where he was cutting his pattern. And anyway, I'm just saying it might be worth going back and looking at what he did, and maybe you can get some alternate ideas.
Yeah. If you run across the link and wouldn't mind posting it,
Yeah, I'll tell you what, I'll drop
There you
off
go.
and take a look. Somebody found it?
You found it?
Oh,
Ken?
I found his accelerated donkey car run.
Cool, thank you.
No, I believe that's his run, and that was the run he ran in the inside. It was before that, Carl. It was
Found it. Autonomous rover robot with GPS RTK and novel control system.
Yeah, I think that sounds more like it.
August of 2019.
So anyway, that's all I had, but I thought it was like super cool and super clever,
I
very
agree.
applicable to any of us building mowers, and his architecture is really pretty much exactly the same as my architecture, in the sense that he uses an Apr12 running Ubuntu and ROS, and talking over serial. He even uses cobs as the package, which serial transfer is based on cobs as the package for serializing comms to the RP. He uses RP2040 for the low level control, but it's the same architecture as I'm using. So anyway, I'm just like delighted to have all these problems suddenly solved for me, and intend to steal like there's no tomorrow.
Yeah, cool.
Yeah, he was using the Neo M8P, which is less accurate than the ZF9P. I think it's a little less expensive too. But
Have you guys? So I've got I don't know. Kareem's not on, but I don't know if any of you guys have messed with RTK corrections and getting them from a server. from a cause server. But something I haven't understood yet is, so I followed Kareen's instructions to get my RTK, my ZF9P with the ROS driver hooked up to and producing RTK solutions using corrections from the RTK to go correction service. But apparently the ZF9P is capable of accepting corrections for, so here's what I don't know. The ZF9P, I do know that the ZF9P can receive GPS, Galileo, GLONASS, and Baidu. I don't know if RTK to go only emits corrections for the GPS galaxy or for all of them, a GPS constellation or for all of them, or if you can get corrections for all of them.
I know he was using a local. Somebody who was broadcasting the corrections, and he said if he was within a couple of kilometers of that
10
station,
kilometers, I think,
he could use. Yeah, he could use those effectively.
Yeah, and I'm using
6.2 miles.
I was
Not very
using
far.
a correction station up in Prosper, I think it is, which is about maybe about 10 kilometers, between 5 and 10 kilometers from my place. So haven't built all of the software, like the RTK lib software that lets you properly analyze how its performance. But I was wondering about corrections for these other constellations.
Well,
I kind of got the impression it did them all.
yeah.
But
Oh, really?
you know, to get that kind of accuracy and stuff. But I don't really know for sure. But I don't have that luxury. I had to make a base station because I'm not 10 kilometers within anything. So out here, it's yeah. So,
Really? There weren't any stations near you, Ray? Whereabouts do you live again?
well, my mailing address is Blue Ridge, but I'm just inside of Fannin County, which is Blue Ridge is actually in Collin County, northeast Collin.
Okay. You've looked at RTK to go for nearby base stations.
Yeah.
Okay.
Yep.
Well, that's all I had, but it's pretty exciting.
So does this is this going to force you to rethink your Mobot design? Are you going to redo from scratch, or
No, not at all. It fits in exactly with the Mobot design, because I'd already planned on RTK GPS and mounted it. I actually installed it. Let me see if I can point the camera at it. So probably can't make it out, but sitting on top of Mobot, pointing backwards, is the Oak D Light camera, and that black round thing at the front of the battery pack is the GPS antenna. So that stuff's ready for commissioning. I pointed the camera backwards because in one of the previous episodes, someone pointed out that, hey, it doesn't matter which end's the front. I can call the back the front and it worked just fine.
But the software nestles together pretty nicely too, not just the hardware architecture.
Yeah, it'll nestle together real well because he uses command vel, the standard, which is a standard ROS topic for issuing driving. Oh, there was one more thing I can demo if you guys are interested, and that's map creation. But I it uses the standard ROS joystick for driving the mower, and standard ROS topics for GPS fixes. Well, okay, with some caveats that the standard uBlocks receiver emits lat long coordinates, but there's a ROS package that can convert that into UTM, and then from there you can do a mapping, a transform to transform it into a local XY coordinate frame.
So you're saying this is a poster child for kind of standards-based interfaces.
Pretty much.
So
nice.
there's not going to be any issues like he used the Ardu simple RTK and hardware wise, it doesn't matter what.
I don't believe so, because it, he ultimately, if you look at the topics that he publishes, he's mainly working off of /ODOM, and /ODOM is well defined in ROS, and he maps his RTK data stream. He actually has a local base station, so he gets NED coordinates from the GPS receiver, which is the position north and east of the base station, and then he feeds that into ODOM, and then the ROS nav stack runs off of ODOM. So it all just like plugs together, and I just need to plug in a little bit differently in terms of taking lat long, getting that into UTM, and then into a local ODOM. But that's like trivial.
So does
Cool.
your RTK board have a radio on it to get that information, or?
I'm using the network connection to the Apr12. So
Yeah.
I put a big old antenna in my Ubiquiti Rocket M2, which is as old as the hills, but it's like a 2-foot tall antenna in my attic, expressly for putting Wi-Fi out into the backyard.
Wi-Fi, yeah.
And I've got a rocket. I've got a Ubiquiti station. I forget what Pico station in the mower that connects to that, and I've tested it for range, and it reaches all the way down to the lake and a good distance either side of my property. So I don't. So I guess there are two answers, Ray. One is I plan to use internet access through the Apr12 and the Ubiquiti home Wi-Fi network, and the second is if I go out on site, I would plan to use one of these MiFi units and give it access to the internet to get the corrections.
Yep. Yeah, SparkFun for a long time they sold. It was one of the 915 megahertz radios. It was not LoRa, but that's what they were using to communicate between. They had one on the base station and one on the rover, and that's how it got the correction data. So
right, and I've got one of them too from a previous project, and really just about any comms mechanism from either a base station or from the internet for online corrections will work.
Yep.
So
yeah.
That's my part. That's a system integration part. But I really feel like he's done the hard work here of and really clever work with that slicer approach.
So I wonder if it was like G1, G1, but X and Y are actually latitude and longitude, I'm assuming.
You wouldn't
What do you-
want to
what do you think,
use
Doug?
lat long because those are in degrees. You'd want to use M
Oh,
um, at least as an overarching framework because that's expressed in meters of northing and easting. But then using Ross TF transforms, you can transform that into a site local coordinate system. So you can orient the coordinate system relative to like the southwest corner of your property or any arbitrary point.
mm-hmm. Hmm.
Cool.
You're muted, Doug.
You're on mute, Doug.
I was just saying that I believe that was developed by the military to provide maps for their people so that otherwise the maps are in X and Y and instead of latitude and longitude. So don't
Probably,
you also have the world is divided, if I remember right, into 64 blocks. So you have to know which
That's correct.
block you're in.
That's correct.
Yeah.
60 actually.
60. Okay.
Imagine you have a problem if
60
you're right at the
orange
corner.
peel segments.
Yeah.
Yeah, it only works up to 80 degrees of latitude, plus and minus 80 degrees of latitude. It's not spec for use beyond that. But if it's just fine to be at the corners of each orange peel segment is sort of like chopped flat at the top, and then it kind of curves outwards, and then it has a flat horizontal piece, and they're layered one above the other in what are called zones. And so there's like, I forget how many zones there are in the northern hemisphere and in the southern hemisphere, but you end up with this. I don't know what to call it. It's sort of trapezoidal, but with curved sides. But it's linear enough within any given zone to work.
I'm assuming they don't do it above 80 degrees
You
because
muted
there's no grass up there anyway, right? To mow.
Right.
There you
Too
go.
far north.
Right.
Yeah, it was kind of interesting to find out how non-spherical the Earth actually is. It's kind of bulges out at the equator, but it's kind of like flat between that and the poles. And you think, oh boy, it's not a perfect sphere. It's just a big rock spinning out there in space.
But I've heard if you shrunk it down to the size of a basketball, it'd be a lot rounder than a basketball.
Hmm.
I think it's about 300 meters flat at the pole. At the poles.
Oh, 300 meters shy of a perfect sphere?
Yeah, and bulges at the equator.
Yeah.
Is that where the Flat Earth Society gets their data?
Must be.
Could have been.
Yep.
Some of them were right,
All right. So who's got something next?
Well, I just want to say real quick, just in case somebody hasn't gotten this, if OpenCV is just shown that Jesse's going to have a talk there. Jesse mentioned he was going to give another talk in a week. This is it. Let's see. I can.
Is there a link you can post for that, Doug?
Yeah, I'm just gonna. If I can get to it here. Yeah, this. Are you guys seeing it? It says using spatial AI for navigation with Lego and OpenCV AI kit. Do you see that?
Yep.
Yes.
Yep.
Okay, so it's on the 14th, 9 a.m. Pacific. So I don't know what that is for us. That's 3 hours one way or the other. I guess 3 hours, so it'd be noon for us. I don't know. So, yeah.
Could you
Yeah, probably.
Yeah.
forward that
So-
around or something?
Huh?
Could you forward that around so we get the electronic link?
Yeah, let me see if I can get to a link.
I think Pacific would be 2 hours out from you guys.
Yeah, see, I'm afraid it might give me
You're
this
right, it is too.
humongous link that I have from my email, so I'm not sure it's really a good link. Let's see, do they
No,
have?
3 hours.
Let's see what this one does.
10 to Zoom.
Okay, I'll just copy this link here. Probably tells you copy. All right, I'm stop sharing and I'll put the link in the chat.
Yeah, it's
Alright.
Pacific, Mountain, and then Central. So that's 2 hours from you guys, right?
No, 3, I think. Isn't it?
Pacific is 2 hours after us.
2 hours? Okay.
So it's 8:19 here. It's 6:19 in the West Coast.
Yeah.
PM. And it's 9:19 in Connecticut, I think. But Canada, I don't know. They're so far north towards that flat roof of the world.
Yeah. Above the
Yep.
80%, 80.
9:19 here.
Almost ready to fall off the turtle's back.
Well, I thought the Earth was flat, right? So then you're gonna just fall off.
Yeah, off the edge.
Turtles all the way down.
Okay, that's the registration link, which is good. CV weekly webinar. We have to do a little research and find this out. Huh. Okay.
I'll forward the message to the list. Okay. That way everybody will get the same email. I'm sure I'm in some sort of weird campaign group and all that, so that's probably a humongous. Okay. All right.
All right.
Hey, Paul, look who jumped in.
We got Harold and Kareem. Welcome, and
Look at the
Ed.
devil.
All right. So who's next? Who can help us carry
Who's
this
evil here?
conversation?
I have a question.
Shoot.
Since we're on the topic of navigation and global and GPS waypoints and stuff, when I was working on the Robo Columbus last year, I was taking my GPS coordinates when my GPS was working, and I was converting basically from my start to my end, first target, and I was converting the GPS coordinates to XY coordinates. Is that what everybody is doing basically?
Yeah, I forgot about that, but yeah, it's like I think it's you convert to nautical miles and then to actual meters, I guess. I haven't looked at what the calculations were, but yeah, you're right. Degrees are the
Can I
latitude and longitude is in degrees. So
can I present?
sure.
How do I present? Present now.
Hit the box. Yeah.
Yep,
yeah.
that's the one. You're not presenting. There.
Right now.
Now.
If you look at equation number 5,
Yep.
Convert GPS lat long to robot XY. What that requires is that you've identified the starting point. Basically, that's 0, 0 on my robots where it came out of reset. You've associated that with a latitude and longitude that are defined there as base lat and base long. So basically, that's the equation you were talking about, and it's the fact that longitudes are weird curves and not straight lines is why you have this cosine lat plus base lat divided by 2, etc. So that's how I do it. But actually, since I'm not going to use the IMU's definition of north as the same as the axis of the local axis of the robot, I want that rotated from the local axis of the robot. So equation 6 does that.
Dave, can
Is
you
any-
put that link in chat? That'd be good.
Yes,
okay.
please.
Let's see, stop presenting.
You're not using ROS, right, Pat?
I wasn't using ROS for my outdoor bot.
Good, thank you.
I may go to use it and reuse some of the routines that I had for navigation.
Okay, because there's a package that does a conversion from Latlon to UTM, just FYI.
But that seems kind of odd, Paul. You're going to a Mercator projection in order to then go to a rectangular projection. Why not just do it directly? It only takes one cosine.
Well, I want to say, isn't that also, if you're using just, I don't know about the RTK, but for just normal U-blot GPSs, you can just use their utility to get the format that you want.
For me, Mr. Anderson, I can always go off on a tangent, but going off on a cosine, man, that's just deadly. Just saying.
Well, look, our little robots, I mean, we're not sending them to California, you know.
You raised a good question, David. And
If they move, you know, if they covered several square miles, that's still basically rectangular, you know.
it's a good question, David, and I don't really have an answer.
That was my assumption as well, because in the Robo Columbus, we're talking about, 300 feet, I think it was.
Total distance, yeah.
Total distance, on a leg. It's not that much. And that's why I was using a formula as well to convert from GPS to assuming starting at 0, 0, pointing north and, going in that direction.
As I say, I think for the scale of our robots, you know, you can just assume that the Earth is flat and the coordinate system is square. You do have to correct for the cosine of the, you have to correct the longitude for the cosine of the latitude. And I said,
So basically,
I
since
said
my
that.
indoor,
I'm sorry, Pat, go ahead.
since my indoor robot was working fairly well, to track XY coordinate, I figured on reusing the odometry and everything out of that waypoints, calculate the waypoints from the GPS coordinates that I receive. So that's why I was looking to basically just, instead of going to UTM coordinates, is to try to do it like David did, basically using a formula.
I know Scott said that that's what he did originally, but that after a while he blew that off and he just, his navigation routines just read lat-long directly. He didn't find a value in converting it to the robot's local XY coordinate.
So lat and longe would be a whole other problem, because I have not been able to latch onto satellites reliably, even though I'm in a wide open field, and apparently the satellites don't go there.
Not enough grass again, I think.
Yeah, I found a lot of times when I was testing at night, I got a great signal, but then during the day, like especially in the summer, I'd be outside and a thunderstorm or something would start rolling in and I'd lose my GPS.
Oh, I'm talking like a beautiful blue sunny sky, and just refusing to latch onto a satellite.
Maybe you're just too close to the edge of the world. So
Yeah,
Like-
too close
like
to
when
that flat spot in the north.
when you get a lock, how many satellites do you see in view? Because I know here in Dallas, I often see 7 or 9 or a lot
It's
more.
anywhere from 5 to 7, sometimes 9.
Yeah.
And it's not like I haven't used GPS up here. I go hunting and I use it all the time.
Huh.
And I've tried 3 different modules, the cheapy little GPS modules, and not really had much luck with them.
It's just GPS on the robot then, not a handheld GPS or your phone.
My handheld GPS will latch on.
Wonder if you need an antenna.
I've tried that with and without antennas on the GPS modules.
Doesn't matter. What if
Were
it's
you
local
careful?
noise off the robot platform? Maybe.
Were you careful with like the cable length and the connector insertion loss and stuff like that for the antenna?
So it came as a kit with the cable length, about an inch long.
So yeah, you're
Optimized for you.
that's
Yeah.
good.
Hopefully.
It was
Yeah.
it was old eyes can't solder those little SMA connectors on there.
Mm.
And those RF guys are so picky.
But yeah, they are.
They
My
have-
50-watt soldering gun doesn't seem to cut it.
They have the problem that the signals they work on won't stay inside the wires.
You just bounce off. Boing, boing. Yep. And
Or if the
It's-
wire
I have a problem with all those RF guys because you've got male, female, then you have reverse polarity male, reverse polarity female, and then you've got, which one are you using and what you're actually trying to do with all that? I just, killing me here. The store never has you always have the exact opposite one you need that you find in the store if you can find them someplace.
I get these 12-inch. I get these 12-inch lengths of SMA extension cable, and they come with a full kit of male and female and reverse male and female adapters. So you can order them on Amazon. They pretty much have everything. It is kind of scary, spooky in a way to look at. Yeah, just like that, Ray. And it is kind of scary to look at the satellites and the constellations that they're in, because I would say that the ZF9P picks up about a quarter of the satellites GPS, quarter of GLONASS, quarter are Baidu, and a quarter are whatever the other, Galileo. So it's like everyone's got their satellites looking over us. It's kind of spooky. But since Kareem's here, maybe Kareem can answer my question from earlier about providing corrections for other constellations. Does RTKD go provide corrections for all constellations or only for the GPS constellation?
He's looking it up now. Okay, no.
Kareem?
Sorry, I'm in the middle of transitioning from one computer to another because it's messed up. So I'll be back in just a couple minutes.
Yes, nowadays, do you want Russian satellites looking down upon you? I don't know. Maybe not such a good idea.
well,
Yeah,
at least we're not looking
right.
at Finland, right?
Whoa,
Yeah,
we're
that's
I
true.
heard the Chinese are doing the same thing. Their satellites.
Oh, that's true. Chinese, Russian,
What's the difference? China, Russia, Google, they're all tracking me.
So speaking of being off, using degrees and being on the Earth, out here in the West, we have roads that go on a grid, and every 24 miles, the north-south roads have to take a dog leg so that they don't intersect with each other.
Every 24
Otherwise,
miles?
they converge, right?
Oh, wow.
Really?
Oh, the problem's even worse up where Pat lives, because if you look at that Mercator projection, things are getting bigger and bigger as you go toward the pole, till when you finally get to the pole, it's the same size as the equator.
Hmm?
When Pat walks north, he gets fatter.
Oh.
Now you're getting awfully personal.
Oh, sorry. Yeah,
It's just the fisheye lens on my camera.
the advantage of Mercator projections is that if you're plotting a navigation course, you're at sea, plotting between two lawns produces a straight line on the map, which is not what it would do on an actual globe. So that's handy, but the distortion gets worse and worse as you go toward the North and South Pole, till, as I say, when you get to what should be a point, that is the pole itself, it's actually a line the same length as the equator. That's what makes Greenland look bigger than South America, for example. So, on the other hand, if you sail your sailboats mostly around the equator, it's probably just fine. The geophysicists use a sinusoidal projection a lot, which is kind of a weird thing to look at, but has the advantage that the ratios between everything are correct. It looks like if you took two sine waves and put them one on top of the other, where they joined together was the pole. So it has some mathematical advantages, but this whole 3D Earth is really not handy at all.
I mean, why don't we just think in spherical coordinates?
No, I'm just saying that the reality of the universe is just hard to model.
It's a mess.
Flat Earth Society doesn't have that problem.
So I heard something earlier. Sorry, I had a lot of audio problems, but I heard something earlier about converting to X and Y or something like that, geo coordinates, and going with Carl's comment. What I do is I just use because all of our stuff is on Android, and we just use the built-in mapping APIs basically, and there's a basic function to get the bearing to something. And so we do it always, it's more like polar coordinates, right? So it's always a bearing to something and a distance to it. And we never even bother when we're doing outdoor stuff to convert it to an X or Y. Right? It's just distance and bearing. Paul, you were asking something else about GPS earlier, and I didn't quite catch that either. I'm sorry.
Yeah, you pointed me to RTK to go, and I've got that going, feeding corrections into my ZF9P, and it works great. The ZF9P reports it has an RTK fixed solution, but my question was, the ZF9P can receive all 4 constellations, and I have to imagine you need different corrections for the other constellations beside GPS. So my question was, does RTK to go supply corrections for all constellations, or what do you do? Can you make it do RTK for? I've read you can make it do RTK from all 4 constellations, but I'm wondering how that works or how you do it.
I have not researched the details on that. To me, having it was more about acquiring signal faster and more robustly, I guess, in terms of having multiple constellations. And once I have enough, I can't say that like the Chinese constellation or something is involved in it or not. I have no idea. But we get plenty of satellites. You get a good lock, and then it just seems to go a little bit faster. So I'm assuming that there is some way to share that information across the constellations. Remember, the correction data is just giving you corrections for like atmospheric disturbances, right? So, and it's really just a timing signal, and they're all using the same timing. So it probably is applicable. Like if you just
Oh,
yeah, so it probably is, but I don't know that for sure.
oh. Because I know there's a mode selection in the ZF9P as to whether you want it to use GPS only, or you can basically select which
Yeah,
are all,
I have all of the constellations turned on all the time. So, and I haven't.
and you're using RTK.
Yes.
Oh, okay. Well, thanks. That sounds like it answers my question.
Okay. Cool.
Thank you.
Yeah, Paul, I don't know if you ever saw Kareem's. I guess he had lights on an outdoor platform, and he could write things in light, basically. With I thought you were using RTK with that, weren't you, Kareem?
Yes.
Yeah.
Yeah, that was the only way I could get the kind of we were calling it geoscribing. So basically, a way of like either pulling a rake across dirt or with a robot, or at night we were turning on a bank of LEDs and then filming it with a drone from overhead. And so we could, there it required time lapse, but you could create, text written large on the earth just by moving your robot around, and it was all,
Wow.
yeah.
Cool.
But that was all
Yeah.
that all required RTK, and again, going back to the previous discussion, it was just get bearing to the next point, and start moving that direction until you got there. Then look for the next point.
A lot of the things had 4 letters, like DPRG.
Yeah, you run out of space pretty quickly when you're doing large letters. It's like then the drone has to go really, really high. But yeah, we were using it to draw the my robotics team they have team numbers, so their number is 6832, and so for them they wanted to have it write that out. So. And DPRG happened to be about the same size and worked nicely on the beach in South Padre. So, yeah. Oh, I'll just report real briefly. The team competed in the state robotics championship this last Saturday, so I wasn't able to attend the other meeting, but we got the design award at the state championship, so we're happy about that.
Good. This is for the
Yay.
expanding platform.
Yeah. Yep.
And did they ever get that expanding robot to be controllable?
Yeah, they did. It's kind of amazing what it can do, and it can probably hop over those little barriers on the field better than any other robot that we found. It's less about the control algorithm and just not spending the time to learn how to drive well. Constantly working on the robot, the drivers don't get access, and there's still some code issues that didn't really get cleaned up in terms of the automation. So its navigation without human drivers is not so good right now, and so they didn't quite get to the point of, and their autonomous modes, they didn't quite get all that figured out. It was a more complicated. They bit off more than they could chew in terms of complexity of this robot. And the amount of time they had available this year, particularly with so many seniors doing senior trips and things like that, applications, it's been, they didn't quite get as far as they wanted to get. But they're still proud of the robot. I'm proud of the robot. They pulled off what is probably one of the most complex robots in FIRST. Maybe throughout the entire history of it. So it's definitely interesting.
And the design award, I mean, that's no small award, right?
Yeah, no, it was good. This wasn't the advancing They this year they only did like 3 advancements from the regionals to worlds, so they didn't make it to worlds. But they did make it to state. It's weird that state doesn't advance to worlds, but that's the way it is. And but yeah, they had a great season and pulled off an amazing robot. So I don't know if we'll get a chance to have them present what the final result was or not this summer, but maybe I can get them to do that. But that robot is probably the one that we would enter in the contest if we have the what's it called, the one with the picking up the gnome and the
Oh, yeah. Retrieval one.
yeah.
Well, that would be cool. At least one entrance in that then.
So,
that
so
is
state
the plan, yeah.
competition is not leading to world. Is that something Governor Abbott did or something? Or
No, it's weird. It's basically under the UIL, University Interscholastic League, and it's and so it's a different body presiding, and they don't, yeah. So it's kind of strange. It's sort of more under the academic competitions, and it's just not tied with the National First organization. So.
Well, that's good. That's positive news.
Yeah. Sorry, I think I may have jumped in. There's probably an order that you guys are going by.
I think the order is that we're welcoming people who jump in because we're a little dry tonight.
All right.
I can show you some stuff, I think.
Excellent. Harold.
I'm going to, if you want to pin me or whatever, you can see what's going on. I will tell you, I managed to, hold on. I'll just put my wheels on it so you can see it good. You're not supposed to be looking at me. I'm supposed to be looking at some of my wheels. You'll notice they're slowly turning a little bit, but that's just because I don't have the continuous things configured right. I was able this last couple of times to make all the wheels go forward and back and turn left and right. Of course, they have no idea what they're doing other than all the servos are acting the same. Now I've got to go through the thing and make them configured so I can actually make when I push forward, that all the wheels actually will drive forward instead of going forward in their orientation and things. And this is all running under ROS 2, and I've got all the nodes working up together, and we made some pretty good progress the last few streams. And the other thing is I do have a giveaway going on. I think have I sent it out to everybody? Maybe I haven't. I'll make sure I send it out to the list. That I'm giving away $100. And it's one of these things where you can sign up for it, but if you want more tickets to sign up, you can come by my Twitch channel and do a whole bunch of other stuff and do redeems and all those kinds of things. And you're like, well, okay, that's cool. So is it doing you any good, Harold? Well, I will tell you on April the 4th, Monday a week ago, when I fired up the stream and launched this out, I had 217 followers. Right now, as I'm looking at my board on it, let me make sure, because I don't want to lie to anybody, I have 331 followers in a week. And hey, Ross, how you doing, man? Ross has been coming by and seeing me. Things to say, a lot of things, and I think he's done. I haven't got to try his micro Ross yet thing going on, but I will be trying that here before too long, I think. And so we've been having a lot of good times and figuring out a lot of things, banging our heads in the wall, and yeah, that's about all I got right now. I don't know that moving wheels and things actually does much of a robot, but compared to what I had even a week ago, none of this was actually doing all of it. And so I'm getting more. This is the smarts. This has got the latest and greatest running in the Docker container and all that kind of stuff. So hopefully I'm on my way to eventually making the camera do something, and then having some I've got to work on the different drive modes. Anybody got any good resources? So I can go look it up. I can certainly go look it up. But if we have good resources on how do I do calculations for doing Ackerman driving versus other things like that, how do you do that? Because I got two radii going here, and I would like to do something more. What the like the Exomite guys did, they call it fake Ackerman, and they basically turned all the front wheels and the rear wheels at the 45-degree angle and told it to go forward.
I got you.
And so I'd like my robot to be a little smarter than that. So when I want to turn right, I don't want to turn at a 45-degree right. I would like to turn a little right or a little left, those sorts of things. If anybody has a description of what all that math is and that kind of stuff that you like, because I bet there's tens of thousands of them out there. But find one that you like that you think you can understand well. I would appreciate that greatly. And
David Anderson, I thought, had a pretty good explanation of it. As far as
and I've seen him do it before. I've seen him do it and show it. Not that I didn't pay enough attention. I just didn't have time to digest all that it was in there. So, I'm I can go search for this and beat my head up, or I can use all the vast knowledge I have on my screen right here and use it.
Well, your rover's not actually Ackerman, is it?
What now?
Is this for your rover? Because that's not Ackerman.
No, it's not. However, they do Ackerman steering sort of thing where you have both rear wheel turning and front wheel turning. And what they do is they do a fake Ackerman, which basically turns the wheels at 45 degrees on the front and then minus 45 degrees on the back, and then just says go forward. And I would like to do better than that. But maybe I'm overthinking it. Maybe that's all I really need to do from what robot's going to be capable of doing. A lot of unknowns. I'm to the point right now where I haven't gotten this far before. So I'm on my streamer like, okay, what am I supposed to do now? I got all the wheels moving, and now where do I go? Right? And that was back to making it move before. And I don't have the spin stuff doing, and I don't have the spin or the crabbing or that kind of stuff that's going on there.
Well, Harold, if you'd put it down on the floor, you could get a gold star.
That's got a problem. It's on shore power right now, so I don't have long enough. Well, maybe I do. Hold on. Let me see what I got for the.
We love those gold stars.
Were your center wheels steering also?
They can.
So you can crab.
I can crab. Yes, sir.
Okay.
Okay, let's see. Now that's not the rover. That's Poe. See what I got going here.
That's what we're trying to get to.
Yes, exactly. I don't know that you'd want to be Poe. Oh, I need to get rid of that. Don't need a monitor. No, I don't know that I'm going to have enough.
It's always something.
It is, isn't it?
Needs some of that wireless power.
Yeah, and I could do that, but I just briefly do all that, and I don't know when I'm ready to.
Harold, you're still going to get a black star.
Can it roll over something half the wheel diameter? Just let it roll over everything.
but not
Okay.
the
So, get some more light. I got right by my thing. I think I got enough power to make sure people are seeing things.
Uh-huh.
Okay.
All we're seeing is your foot, Harold. You're just off
We
the
saw
road.
the corner of the robot move. It moved.
There you go.
Yeah,
There it is.
try it again. Look at that.
Yay, it moved.
All right, gold star. Gold
Yay.
Because the robot because it's not smart enough to know that the right side wheel should go one direction and the left side wheel should go the opposite direction to actually go forward yet. So we just got all those moving on the last string, and all they do turn, and I can turn them just a little bit, but it's not smart enough to crab either. So
I don't actually know that I've ever seen a control algorithm that would, I think you're going to have to develop it, Harold.
yeah, I mean, they've got some stuff in there, but it's like I guess I can. I mean, I got to go pick out my cosines and my sines and my angles and a couple other things to figure out what that's going to be. So yeah, because I would like to do what is it? How do we put back up over here? You know, instead of I would like to do one of these, and it's easy enough to go, that kind of thing. But I would really like to be able to make that work where the front wheels are turning and the back wheels are turning the right kind of thing to make the arc happen. We're going around it.
Well, for sure, to use the elegance of that particular and the flexibility of that particular platform and the software that you seem to have that they gave you is sort of a bang bang controller, which is a weird thing to have on such a slick platform.
Yeah, I thought the same thing. This has got to be a little more sophisticated than that. You know, when it comes to the spin in place thing, not a big deal. You just crank them all and you do whatever. And then the crab thing seems fairly straightforward too on the angle of stuff, right? So, and I haven't written those nodes yet, but I think they're going to be more straightforward than the Ackerman thing for doing the angles. And I think there's also, I was doing some quick quick thinking on it. Where did that go? Oh. I was doing some. Oh, that's what I use for my when I take bio breaks. I use a sophisticated sign on my stream. Everybody else has animated this and flying around. I got a piece of paper. I upgraded. This was a yellow pad, but now I got engineering paper. I'm all kind of slick now. Because what I know is I know my body is so big, and I've got some wheels, right? And I know there's going to be some radius point out here going to this midpoint here. So this is one radius here and another radius here, and then that's some math, right? And I can figure out. I should be able to get this angle here at some point, and then make that the complement of that angle to know where to turn the wheel. And I just haven't done trigonometry in a very long time, and I was hoping somebody else had already done that.
Harold, I think the hard part is going to be as that point that you've drawn outside the base
Right
there, as that point moves closer and closer to the robot and eventually passes in underneath the body, so it's within the body of the robot.
Yeah.
How do you do that transition?
I do not know.
One massive lookup table, maybe.
Maybe, or maybe because I think I don't want to do a lookup table on what these angles need to be, but at some level, I bet I could do a calculation here and know what the min radius I can turn is, and then based off that minimum radius, then do some of your transitions like you're talking about. Because at some point,
your minimum radius is 0.
0, yeah.
On that one. We did, my team did the same thing. They've got a hybrid, is partially 2 differential wheels with 1 swerve, like those steerable ones. They had to do exactly what you're drawing right here. They had to create a mathematical model that described how it went. It turns out that there weren't any transitions required. I mean, it just they were able to work out the formulas such that regardless of where the center of turn is, that it could calculate what each of the wheels needed to do.
And Kareem, there wasn't any transition involved when you moved from spinning in place to spinning to around some point outside the base?
Nope, there wasn't.
So what
Cool.
you're telling me is I don't need to worry about that if I do this one correctly. Is that what you're telling me?
Uh,
If I do, I'm calling it Ackerman now, and it's not really Ackerman, it's whatever it is.
Mhm.
If I do this one correctly to model this thing going to 0, to make that thing do the right thing to just spin in place because of that, then the only other thing I need to worry about is how the crab works, because that's not going to go to 0.
uh,
yeah.
yeah, that's
It's
right.
gonna be something else. Okay, I will
You're-
go forward with that.
You're on the bleeding
Well,
edge there, Harold.
even the crab is probably, if you think about it, you can crab in any direction,
Well,
right?
yeah, you can crab in any
And
direction, right?
you can actually mix crabbing with a continuous curve.
I guess you could crab in a curve.
Yeah, and you're gonna have to do what David did and others. You know, you're gonna have to start turning the robot around while it's moving in another direction, and to just, you know, level up and prove us all wimps.
Yeah, I don't
so-
know. I don't know. It's going to be a little bit of ways before. I don't know. It's surprising. I didn't think I was going to get this done, and the next thing I know, it was done and wheels were moving. In the thing, I was really surprised. So when I say, like you were saying, to attach this to an IMU and tell it to head north, and then I turn it around and it figure out where it's not north and how to turn back in. I think I'm a little ways away from that, a little further than other things. But
Well,
right now,
Harold, my question is more elementary, or at least I think it is. If going with your drawing right there, let's assume that the robot is arcing to the left. So that means that the front wheels are turned, the inside front wheel is turned away from the body of the robot, and the inside back wheel is turned toward the body of the robot.
yep.
Right? Okay, so now we're going to make that turn tighter and tighter and tighter, which is the equivalent of moving that point in closer and closer and
Yeah.
closer. Okay, until that point starts to pass in under the body of the robot. Now stop right there. If you put the point directly under the body of the robot, what you're going to have is the two front wheels are both going to have to be cocked in, and the two back wheels are both going to have to be cocked out. So how do you make that transition? That's the question I'm asking. You have to make a transition from where the wheels, the front and rear wheels are moving together but opposite, into which the sides are moving together but opposite. When you pass in under the body, in order to rotate in place, the front wheels have to be pointing toward each other. Whereas when you're turning the real tight turn right up to the very last moment, they're both pointing parallel to each other.
Yeah, I think that's why the ExoMy guys went with 3 of these to not have to worry about that edge case, and said if you're driving it like a car, we're going to drive it like a car. And then if you want to spin in place, you're telling us you're spinning in place, so then I don't have to worry about that and just do this number, right? And then well, of course crabbing is whatever crabbing is.
Well, I could see if spinning in place is like a separate function that you call,
Yeah.
but that would be when the point you're trying to turn around is exactly under the center of the robot. But what if it's not? What if it's just an inch or two off from the center, but still within the body of the robot? Let me back up a little.
Yeah, I think I see where you're going. So it can actually still try to make that turn, and not.
Suppose you were just doing scrub steering, so the wheels remain parallel all the time.
Okay.
You're just driving them at different speeds.
Yeah.
Then as you slow down the velocity and the rotation remains constant, that point will automatically move in underneath the body of the robot until you're rotating in place. In that case, rotating in place just means 0 forward velocity.
Yeah.
Okay, so there's no actual transition like Kareem was talking about. But it seems like in this case, as that turn gets tighter and tighter, at some point you're going to have to suddenly
Flip
the wheels in order to have it continually get tighter as it passes underneath the body of the robot.
It's like tangent of 90. There's going to be a discontinuity there. You know?
Yeah.
So am I missing something? Because as I look at this sketch, I'm imagining that basically the idea would be that So with your pen now, and Harold, your drawing is a little offset to the right, so you might want to push it to be more left in the frame. Yeah. Okay. That's all right. So basically now, so like you put that pen anywhere else, you put that pen anywhere on the page, all right? So you just put the tip of the pen anywhere on the page, and now what you do is you can imagine a straight line from that pen to the center of all 6 of the wheels. And it strikes me that what you're really wanting to do now is that if that pen, that point that you have with your left index finger is the intended pivot point,
Yeah.
then what you really want to do is you project that point to the center of each wheel, and then you rotate each of the 6 independent wheels until it's normal with the radius to that point.
I guess you could limit it and just
Yeah.
say that if you want to do Ackerman steering, that you can only go so close to the center point of the platform.
No. That's a different thing. What I'm saying, Ray, what I'm saying is that wherever you put that point outside the robot, then you draw a perpendicular line to the wheel, or you turn the wheel until it's perpendicular to that line out to the pivot point.
Right.
And now what you've done is by projecting the point you want to turn about, you've now figured out a way to compute the angle of each 6th wheel to turn about that point.
So in this case, to make it sort of simple, the normal to those center wheels will be, let's say, we'll just make the normal here, right?
Yeah.
And so if I move this in, because these wheels will turn a complete 90 degrees, so I could actually turn that, so that would be the normal. Now,
Yeah,
I don't
for
know
that-
what kind
for that
of
wheel.
wheel to do, but I get that. But that would be one normal, and that at that same point, that would be a different normal over here for turning.
Exactly.
That wheel, right?
Yeah.
Hey,
Still,
David
the normal
Anderson.
on these 2 wheels will still, these won't even ever turn in this mode because they're still just normal to this. Where the center point moves along that thing. So what I'm really doing is finding the normal to the
Of
circle
the outer ones. Yeah.
Yep.
on the outer ones.
Yeah.
Hey, David, isn't that kind of a definition of Ackerman, though? There is just based on the distance between, turning points of each wheel and the 2 axles, or axes, I guess. Ackerman, you can only turn so tight. So that would work for a definition, but I don't think
Really, the word Ackerman probably shouldn't
to
be used.
rotating in place.
Yeah, this is probably not really Ackerman.
Ackerman has a very specific
So
meaning.
maybe this is a
And
different kind of
basically, the rear wheels, of course, don't steer, and you draw your normal to the rear wheels, and so you go out to a certain point outside the body, and then you draw a normal to the 2 front wheels, and they're at slightly different angles. And the Ackerman patent, it was carriage designers that worked this out so their wheels wouldn't slide sideways in a turn. And basically, you think that the steering arms are not parallel, but rather they're pointed toward each other. And in point of fact, they're pointed toward the center of the back axle. And if you do that, it automatically, the one that's turning toward the vehicle, the front wheel turning toward the vehicle, automatically turns less than the one on the other side turning away from the vehicle. It does that mechanically. So really all those things need to be true. The back wheel's fixed, the turning point is a radius outside that's normal to the back wheels and points to the front wheels, and the front wheels have this parallelogram mechanical steering thing that puts everybody at the right angle. And
yeah, David, you had a diagram that kind of showed that. Do you know?
Yeah, I did. I was just wondering where it was.
Hey, Jim, if you're still on the thing, why don't you post that link that you posted to the Discord in to the chat for everyone? I mean, that may be a good starting point, but at least it's better drawing than what I've got going on. That'd be another question too. Does anybody have anything other than a Draftsman pin set and a compass to be able to draw some of this stuff where you can explain it better than my bit of chicken scratch we got here? Anybody have an idea? I mean, I'll go look just because I'm gonna go look.
You're three steps up from a napkin.
There's a concept here that I think is worth thinking about, which is the concept of the center of rotation of a vehicle, and or it's called the origin in four-wheel vehicles, and the origin is the center point between the rear axle in a two-axle vehicle like a car. In this, you could define the origin as being the center point between the two middle wheels, and the point of it is that the vehicle rotates about that origin. And what Carl described, where he had a point down to the bottom left of the vehicle, and he was proposing that you turn all of the wheels at 90 degrees to that point to left rear of vehicle, I think involves crabbing as well as rotation.
Yeah.
And I suggest that it would be easier if you just want to think of the vehicle rotating and keep those center wheels straight, turning at different rates, obviously, for the inner and outer wheels. But that way the vehicle will rotate about that, call that the origin. It'll rotate about the origin.
And it would look equally cool, but a different cool.
Ray, I found it.
Uh-huh.
I found the picture if you want to look at it.
I got
Sure.
it.
I thought it was.
Jim actually in the chat posted a link to YouTube that I'm just looking at the steel thumbnail of it. It has lots of overlapping circles on a six-wheeled vehicle, but they're two pairs of six wheels. They're not they're three wheels in the front and three wheels in the back, as opposed to pair.
Can you see that?
Yeah, I can see that. Yes.
Okay, so that would be the standard Ackerman setup. So you see the
Yep.
the point of center is normal to the back axle, which doesn't turn, and then you get the angles of the front wheels based on this weird non-parallel turning steering mechanism, which basically looks like this. Those angles are the angles if it exactly lined up with the center of the rear axle. So that's what's meant by Ackerman.
Okay. So is this a double Ackerman? So if you extend if you put a pair of wheels on the back side of that, just
I mean, just put it down here.
flip flop. Yeah. So now I've got
Yeah.
6 wheels, and those angles should be about the same, I would think.
Yeah, I would too. And
Well, it's not mechanically constrained like true Ackerman is, but you could model it and you could control it so that it follows that
Yeah.
same
As though it was,
architecture.
yeah, exactly. So this angle here that's produced by a mechanical linkage, you would just have to model that based on knowing what your point of turn was.
Right, and then like switch it around 180 degrees and do the reverse for the
Yeah.
back
Give it
two wheels, right?
Yeah, use that. Use the back wheels as a symmetry line, and then wrap it around that
Yeah.
symmetry. Yeah.
Yep.
Yeah, I foresee that coming. I've got to do some more tweaking and configuration, because configuring this thing was a pain in the. Imagine, I've got 12 servos that could be doing different things, and I've got to figure out which one they're plugged in on, and I don't have the wonderful XOMI script that did it all for us. So I need to go write one of those things to make myself a YAML file with all the right bits and pieces and that kind of stuff. I've not made those niceties happen yet. So I see Ross is running around. I was going to ask him, hey, Ross, you have a good time on the stream when you come down? Because I appreciate you being there. I truly do.
Oh yeah, I'm learning lots. I always get a good takeaway from your videos and stuff, and it's good to see what you're doing. So for sure.
I'm just beating my head in a brick wall, and something comes out eventually every now and then, And I'm glad you're having a good time, or at least a little entertained. and then get stuff out of it. That makes me pretty happy.
Hey.
That feedback mechanism. People ask, why do you do it, Harold? And I'm like, well, I get feedback like Ross gives me, and those kind of things on the thing, and that's some pretty good feedback stuff going on. Pretty good. I do have an OBS crazy question, but I'll leave that to sometime later, and because it's not robotics, not at all. So
I had, as I was poking around here, I also noticed that in that same link that I put in earlier, I didn't actually label what the link was, but it's the one up there that goes to, I don't see it, www.geology.smu.edu challenge-math.html. That if you go back there to equation 3, let me present again.
okay, let me get this back off the floor so the dogs don't pee on it or something. Hold
Am I
on.
presenting?
It's
Yeah.
going
Yes.
along.
Okay, well, equation 3, this is what I believe Kareem was talking about, which just how to calculate the heading and angular distance between a pair of lat long coordinates. And there's a fair bit of math involved in it, but they actually run pretty quick, or my experience is. There's an oddity that you guys will probably never run into. It's called back azimuth. It means when you measure the azimuth from point A to point B, that's not, the back azimuth is not just that, minus 180 degrees, because you're on a, well, it's complicated, but back azimuth is a separate calculation, and it's not simple to start with an azimuth like you could on a Cartesian plane and say, well, the one going the other direction is just 180 degrees opposite. It's actually not, curiously enough. All right, that's all. So that's on that same link.
Cool. Thanks, David. Okay, so anyone else? Right, we're a quiet bunch tonight.
Yeah.
Anybody have some plans for building next week? Things we're going to be working on over the next over the Easter holiday here.
Oh, I
Ray?
was just going to chime in that Harold was asking about a way to draw basically the vector calculations that he's doing. And we've been using an online calculator, graphing calculator called Desmos. And there's a little bit of a learning curve there, but it's been, all the kids are glomming onto that pretty fast. And
Well,
it's
if
been
all
very
the cool
helpful.
kids are using it, by
It's
God,
all about, you got to be cool, man. So
you gotta be cool. All the cool kids are using it, by God. What's the name of that thing again?
Desmos.
DESMOS.
Mm-hmm.
Oh, graphic calculator. Look at that.
Is anybody using MATLAB anymore?
You mean
Can
MATLAB?
anybody
MATLAB, yeah.
afford MATLAB outside of work?
Yeah,
Isn't
it's
there
kind
like
of pricey.
Isn't there like a free version of it that comes bundled with like Wolfram or something with our Raspberry Pi?
Don't know.
There's Octave is a free version of MATLAB.
Which one?
Octave, Octave.
Octave, yeah.
Yeah, or if
Just
you're a
like-
student, I think you can essentially get it for free if you can prove that you're a student.
The student of life doesn't count.
Yeah. No.
Fair enough.
Well,
Decent
Dave probably
businesses
still
avoid
has
those
his
like the plague,
.edu
right?
email address. If you have a .edu email address, you might be able to do something.
They've got the full license at work, and a lot of the grad students, there's tons of little libraries and stuff out there now for MATLAB.
And there was tons of libraries 20 years ago. I can only imagine these days.
When I went to work at SMU, there were tons of Fortran libraries. I even told one of the scientists back then, I was trying to convince her that she should learn C. And this was at a social gathering, and she said, quite dryly, she said, David, Fortran is the language of science.
Oh, Lordy.
And I said,
Hmm.
you know, Latin used to be the language of science.
She said, touche.
No, what she actually said, this is Sue Smerkar. She runs one of the big programs out at JPL now. She actually said, well, if you're going to flatter me, I'm not going to be able to argue with you.
My goodness.
Yeah,
Harold,
so,
I just posted the control award video that my team submitted earlier in the season. It's basically a video from that page that in it they show how they use the graphing calculator to calculate the wheel
okay,
vectors.
cool. I will look at that.
Did you not see the demo that they did? It was,
Yeah.
it was really cool. It was a little interactive thing. You could drag the vectors around and it would calculate the proper. It was very cool.
So historically, I'm wondering, was that the Roman Empire or the Catholic Church that decided, you know, everything that's valuable will do in Latin, so the masses will never be able to understand it because, you know, they don't understand Latin. So,
You're right. The Roman Empire didn't understand Latin, the masses.
I'm still trying to wonder if Fortran is the language of science, then how come they're storing floating point numbers and not actual real numbers in that whole IEEE format thing? That's what I want to know.
You've just never appreciated the glories of Fortran. You know what a common block is? You can
Yeah.
define your variables in a common block, and then you can index a pointer off the beginning of that block and get anything in that block. Read arrays, you know, cross boundaries, I mean, it's just, there's just enough freedom to load that gun and point it right at your own head.
And that's how hackers got in the back door. Index pointers, man. That's how that worked.
It seemed like a good idea at the time.
Now, I'm a big fan of that. When I used to do assembly back in my college days, having jump tables was the stuff, buddy. That was how you got a lot of stuff done, right? But, you know, you had to have everything wired tight or you were off in the middle of nowhere and bad things happened.
Now we just call that multi-threading.
Yeah. Fun.
Well, we're starting to sound like a bunch of boring old men.
Yeah, we are. In fact,
Oh, man.
my wife calls this the grumpy old man night. That's what she
Oh,
calls
my
it.
goodness. So it's
Good point.
I'm like,
Well, since we're sort of talking nostalgia, so I don't know if you can see this. This is how I started out programming in Z80 assembly and writing it down in a little book, and then kind of, you know, translating it into machine code. And I don't remember how I got it entered into my little Z80.
Oh, it looks like
machine
you
I had.
looks like you have the mnemonics, and then over there
Exactly.
the
I had to I didn't have an actual
Yeah.
assembler. I had to
Look.
translate it by hand.
Look, there's a subtract, a constant, and a load and accumulator.
Yeah.
yeah.
I even wrote down what the function was gonna do, you know. So I had a look here of little functions that I wrote, and you know, so fun stuff.
Chris, I'm most impressed by the fact that you still have the book.
Yeah, likewise.
Yeah, it's like it all went when I kind of moved out of home. It all went into a big box in the basement of my parents' house. But bits, you know, every once in a while when I go back to Germany, I bring back a couple pieces of memorabilia, you know. So I have a collection of this, you know, memorabilia from back in the day.
So Z80 was your first micro?
Z80 was my first one. It was a VTech machine. I think that brand it was selling here too, VTech, and they made a Z80 kind of little machine there that you connect to the TV like this, ZX Spectrum kind of machine, and it had a basic built-in, that sort of thing. That was my first one. My second one was a Commodore C16, so that I got a little bit more serious.
Whoa, yeah, that's a big step up.
A
Big step up.
C16.
Well, Chris, mine was the 8051, and I actually made a little board that I could program the non-volatile RAMs from Dallas Semiconductor with hex code, and then turn off the power and would retain it and plug it in my board and do a power on reset.
Watch it hang.
Yeah, right. Watch it go 3 instructions and then no.
Yeah, I'm still amazed by how much they were getting out of those little machines. Like the C16 wasn't a gaming machine like the Commodore C64 was, right? That was the gaming machine back in the day. The C16 had some games, but it didn't have the same GPU kind of that the C64 had with the sprites and all that stuff. But still, I was more interested in trying to figure out how the heck could they get smooth moving pictures out of that little machine, didn't have the same hardware acceleration that the C64 had. So that's what I was trying to figure out. It was pretty fascinating to me. It must have been so heavily optimized by hand. I mean, it's just amazing to think about it.
Hey, David Ackley, were they using the TMS 9918 in the Commodore 64?
No, that wasn't in a Commodore.
Oh, it was not.
They
Okay.
were doing stuff for Mattel though.
Oh, Mattel. Okay, yeah.
But
Yeah.
Dave Ackley, didn't you have something to do with the definition of sprites? Do I remember that story?
Oh yeah, yeah. I came up with the concept of how to do sprites in the hardware, because at that time the processors weren't powerful enough to actually move anything around. And so I came up with the concept of the sprite, and that was built into the 9918, I think it was. And then Amiga, I think it was, extended that. But
the C64 had some of that. I mean, and the Amiga probably could do bigger ones, and the C16 didn't have any of that. So
right.
I kept trying to do it, in software, and it was too slow.
That was the problem. Is the processors didn't have enough power in those days, and so anyhow, I came up with the idea of how to do it in the hardware, and I said, well, okay, anything that you come up with, you need to have a cool name for. And so I said, well, okay, how about sprites? There are things that appear and disappear and jump around and what have you. How about that? And so I coined the term sprite, and that turned out to be now an industry standard for that kind of a thing.
Wow.
Okay, that is cool.
Yeah, it wasn't. I thought you could do, if I remember correctly, 16 by 16 blocks, right? So you could do 16 sprites.
Yeah, it was 16 sprites, and you could do double sprites too, where instead of it being an 8 by 8, it was a 16 by 16. And the idea was that you would specify its XY location, and the hardware would actually put that glyph right there.
Right. So yeah, you had like 1 pixel resolution. You could move it around. And,
oh yeah.
Yeah.
And all you had to do was, like I said, put the XY values in, and suddenly it would be there. And also in terms of the, you specified it as a 8 by 8 figure, and it would you would have up to 16, I think, of those, and you would specify the XY location, and the sprites. One of the colors for the sprites was transparent, and so one of the key things that we did was we had a background where we had a storefront, and we had a car go by, and through the windows you could see the buildings in the background, and then a bicycle went by in front of it, and through the spokes you could see the car in the background. And like I said, it was all in hardware.
So you could, it was almost like you could do priority of layers and
Right,
yeah,
right.
with transparency.
We referred to them as actors, and they were on different planes, and so that's why one could go in front or behind the other. And
Yep.
like I said, it was all in hardware, and it took very little hardware to do it.
Cool.
Yep. Of course, you were in all the TI games. What, the TI 99, that little computer?
Yeah.
Yeah.
9900.
Was that the one
Yeah.
that was basically was just a keyboard?
I don't
Well, I'm not sure
remember.
what you're talking about. There was the 994A, which had
That was the Sinclair. Sorry.
had the processor and all in it, and you could put extensions on. One of the extensions was a Pascal interpreter.
And you could plug in game cartridges.
Yes,
Yeah.
yeah. Yeah,
Wow. Memory lane.
like I said, some of these things are, you got to come up with a cool name for it, and I just happened to strike on one.
You did, and it stuck. It stuck
Yep.
firmly.
Yeah, I don't know if anybody saw it or not, but there was a special on dementia and Alzheimer's, and they, couples volunteered to be part of the study. And this one woman, Sigrid, was concerned that she was starting to show some of the early signs of dementia. She was having issues with like short-term memory, stuff like that. Anyway, her husband, there was a thing where, I don't know, she was thinking he was kind of stuck in the mud, didn't really want to make changes. He had a whole closet of his college notebooks. And she was onto him like for years to get rid of all this crap. Literally a pretty good sized walk-in closet full of college notebooks. And he finally relented and said, and they showed him wheeling out these, box after box of college notebooks, basically, of his. So
I'm like Chris. I still got all mine. I just can't put my hands on them. There's a whole shelf of them here. Looks like about
I
30.
drug some of those around for a number of years, and I looked back at some of them, and I said, boy, I must have been a lot smarter then, because here I work this problem, and I don't even understand the question anymore.
that's right. Yeah. Yeah, I always think back of, all the, like the electrical engineering courses. I don't think I used a fraction of that, it's all that coursework that was dedicated to analyzing circuitry or circuits, and it's kind of.
Well, I
Didn't use
remember
most of it.
people, like you said, who would ever use this crap? And I remember one time when I was at TI, and we said, who would ever integrate anything? Well, it turned out I came up with a problem where I needed to do an integral. I dug out my Dwight's table of integrals, and there it was.
Yep.
But yeah,
Z transforms and S transforms. I mean, when would you ever use those things? I don't know.
I guess Doug may have used a lot more of it. I think he was into, motors and control systems, and I guess if you were responsible for those and modeling, yeah, you'd probably use it, but never had that as a job, so didn't really use it. So
That's the thing, right? It's also specialized. And then once you learn how it works under the cover, then you realize all you need to do is get this library and like plug it in and it's just working.
Yeah, there you go. It's done. So, yeah.
And now
Still, it
libraries
is
fancier and fancier. So
it's useful to know where those first principles come from. Sometimes,
it really is
you need to revisit them.
to keep it in mind, because otherwise you lose touch, right? And you start to forget about why things are doing what they're doing, and you're unable to trace down to the root, like first principles as to why. It's really hard to fault isolate when you don't have that basic grasp.
Yeah, that was one of the advantages I had. Was my undergraduate was in physics, and so in physics we had to go everything down to first principles. That was one of the things that I've started used ever since then. Whenever I get into problems, like when I was at TI trying to design some transistors, and bore down to first principles, and there it was.
So I think that was one of the hardest things for me to get through. I don't know how many years or decades it took, but here you are going through class, and no, this is precise. You have to do this exactly. Then the next thing you do is that, oh yeah, never mind, just drop that term. It doesn't matter. No, drop that term. It doesn't matter. So you just start like, first you worry about all the detail and you say, yeah, just neglect it because it doesn't matter. I was like, come on, get your story straight.
Well, that was the other thing that, like you said, is not only the first principles, but which are the important terms. And one of the things that I did at TI, well, my very first experience in engineering was going and finding the expert that knew how to solve the problem I was presented with, and sit at his feet and let him explain to me how to do it.
I've done that before.
And actually, then at TI, I sort of turned that around, and I went, I heard or somewhere read or heard that some Westinghouse was building transistors in a particular way. And so I went to the expert and said, well, we were having a problem in doing isolating transistors and getting low resistance and what have you. To the expert and said, well, how about like this? And, can't do that, and because of this and this and this. Well, then I said, okay. They have pointed out to me what the barrier is. If I can find a way around that particular barrier, I may be home free. And I was. I exactly did that. So the experts can be useful in sort of a convoluted way in terms of asking, well, can't you do it like this? And they'll explain to you why. And you say, well, why is that? And that's it, because of this. Well, you go look and you see, well, is there actually a corner you can go around? And I solved it and actually made some transistors, shipped some good transistor circuits, integrated circuits. The process they said couldn't be made to work, and even if you could make it work, it wouldn't build good transistors. And it did.
And you can just go deeper and deeper in that. I was thinking as you explained that we think of these devices as digital devices, but they're actually analog devices down at their lowest levels. And if you actually talk to the physicists who go deep into those levels, it's hairy. I saw a lecture one time of partial reflectivity off a frame of glass. That is, some of the photons go through the glass and some of them reflect off the surface. Why is that? God, that's a complicated problem. It's a stunningly complicated problem. And as I say, when you get, well, my dad was a physicist and he taught me that everything is physics. Chemistry is physics. Biology is chemistry. So biology is physics. Everything is physics.
Well, actually, we had Linus Pauling, and he was doing it from a physics standpoint, chemistry from a physics standpoint.
Didn't Linus tell you to, like, when you started feeling bad, just start eating vitamin C until your pee started stinging, and then you'd be all right? something like that. Isn't he the guy that came up with vitamin C?
I thought it was vitamin A in the eye.
Well, vitamin A is a whole different story. You wouldn't want to do that on spec.
Yeah. I think he was what he did go off the deep end on vitamin C. I think it was. I mean, let's face it. All these brilliant people have gone off the deep end in something.
So we all have hope.
Of what? Going off the deep end?
They'll pull up one of these pictures of us, you know, all on one of these Zoom meetings, and then there'll be circles drawn around certain people. Went on to win Nobel Prize, whereabouts unknown, you know.
Now living on some remote island by himself.
Oh boy. Still programming Z80s. That's what it'll be. So in Fortran.
Well, my first real assembly experience was with a 6502, and then the various progeny that followed that. You know, there was a thing, the 8008. It wasn't around for very long because real quickly it became obvious that it wasn't enough. But
well, my first experience on programming a computer was an LGP30, which was a drum computer, and the assembler for it was actually built in the hardware.
Right. One of the projects I helped with was that it soldered up basically a board with a bunch of diodes on it, which was a ROM. And then when you got it working, it was smart enough that you could now read a paper tape reader. Hey, we're home free now.
So you guys are giving all these examples of where you not only got these things, but you programmed them and used them. And I'm thinking, what does this say about my background? Because the first thing I remember was, you remember the ELF microcomputer? The ELF from Popular Electronics in like the early 70s or something. So in Scouts, I somehow, or the thing just after Boy Scouts, I got the sponsor to go buy an ELF microcomputer, but instead of programming it myself, I got other people to assemble it, and I never got to program it. And then that's been my career ever since. So what's wrong with me?
Not at all. Not at all. So much of the software that I have written in my short lifetime is on the junk heap of history. Yeah. You know, languages that are no longer supported for computers that are no longer manufactured.
Well, when I was in college and undergraduate, their computer course was analog computers.
Ooh.
Never
Ooh.
got to play with one.
That's
yeah,
really
you'd have like
interesting.
integrators and differentiators and
Oh yeah, that whole bit.
operational amplifiers that did, you know, different
That's
things.
kind of what the early analog synthesizers were. You know, you had all those modules, you patched them together with patch cables to define their logic, if you will.
Well, actually, they were doing simulations of airframes, and they were using, you know, coils and inductors and capacitors and what have you. And
Oh, cool.
Yeah, I never really used it, but there were all these electrical, mechanical analogs. You know, you could basically simulate,
exactly.
you know, masses and springs and torsion
Capacitors
with
and inductors. Yep.
yeah.
So were there like
resistors and
modules, like erector sets? Could you assemble these computers from not like adders and multipliers and analog?
They were huge patch panels.
Patch panels, right? Yeah.
Patch panels.
Yeah. And if you will, behind the patch panel were various modules of inductors and capacitors, resistors, and what have you.
And when you got that big patch panel set up, there was no save command. You wanted to do it again, you had to set it all up again.
Yep. If anybody unplugged something, you were hosed. You had to go all over again.
Hands off.
Change the equations. Yeah.
But you know that
Simulink is such a thing in today's world. Simulink lets you put together integrators and limits and all kinds of weird things like that, just like those analog computers used to have.
Yeah.
Well, I have to wonder too if our own
Analog computer.
there's some suggestion that our brains work that way. And I think I may have used this example before. My dad showed me this when I was in high school. You have a bunch of data points and you want to try to fit a line through them as best you could. And so what you do is you have a bunch of rubber bands and you put a thumbtack at the location of each data point. And then you slip a wooden dowel through all those rubber bands and you let it go, and bring, it finds the optimal line through that, because, you know, data points further away pull harder on the rubber bands, right? So I suspect that there are things in our brain that work that way, that can do what we think of as complicated, discrete systems of equations that are, in point of fact, fairly easily modeled in analog. And I think, for example, when professional batters, professional baseball players, learn to hit a ball that's not traveling along a standard parabolic arc like it ought to, but because of the spin on the speed of the ball is making some strange pattern through space, but then they learn to recognize those, and they can predict where the ball will be when they swing their bat. So I think
hit
we
a
have,
knuckleball, huh?
yeah, I think we have hardware that can generate, no, I'm sorry, software that can generate hardware when you go over a problem over and over until it's solved in hardware, no longer in software. Up in North Texas, they had a real cool experiment, this was years ago, where they had some neurons on basically growing on a little electronic circuit, and they would fire a pulse, and the neuron would grow to be the length that it was exactly the right length to pass that pulse through. And, you know, if you increase the pulse, it would shorten itself. And if you decreased it, it would lengthen itself. So it was clearly growing in response to this regular stimulus it was getting.
Well, is it that what all the AI stuff is about, is learning patterns?
Or
Maybe they're doing it all wrong.
Like recomputing weighting factors after iteration after iteration. So if the weighting factor is like the length of something, then maybe.
Yeah, the idea that I mean, your baseball example, the person is, if you will, training their neural net to be able to predict where that ball's going to be.
Yeah, or you've seen enough of them that you have some idea of this weird physics that's involved and where the ball can and can't be. You know, there was a thing a few years ago, somebody posted on the list about these ants and how the ants would go away from their nest and find the food and whatever and bring it back. And they appeared to be doing it by odometry, that they were counting their steps. And they proved this because they would either clip the legs off of the ants halfway through the journey, and sure enough, they'd only make it partway back, or they would glue little extensions to their legs.
Cruel science.
And they would overshoot the goal. You know,
We are monsters. We are just monsters. Those things are going to get big and eat us.
And we deserve it. Yeah, I don't know that ants can count, you know, especially thousands of steps, but they might have something like a leaky integrator, you know, that when I walked away, it was about this full, and so it should be about this full when I get back home. And that's a way of counting. Along that same lines, a special we saw on TV pointed out that this wolf, a she-wolf, and she's got 6 pups, but she can't count to 6. How does she know they're all there? And they said that it was because of sort of the corporate smell. When all 6 of them are there, it has a certain smell. And if one of them's missing, it doesn't smell quite right. So she's not counting, but she's definitely keeping track of all her pups. A queen bee in a hive is fed this royal jelly, and tasting the jelly, she says, "Oh, we've lost a bunch of workers. You know, I better lay a whole bunch more workers' eggs." She's tasting the average of the whole jelly, so she's not counting workers, but it has the same function. So I just wonder how many functions there are like that in our own brains.
Deep thoughts. All right, Paul. So you got a call tonight. I think I'm winding now too. Is everyone else about ready?
Sounds good. Sounds good.
All right, guys. Have a great evening. A lot of fun talking tonight. Catch you
Good
next
night.
week. Yep. Night.
We'll see you.